Hello champs, welcome to the channel to know about average speed and average velocity. What is the difference between them? What is average speed and what is average velocity? We know speed is equal to distance by time. But why do we need to know about average speed? Because maybe the distance that is covered over an interval of time, short time interval, is not regular. It's not the same. So in such case, we have this formula. Average speed is equal to the total distance divided by the time interval. Okay. So the total distance can be S1 plus S2. It can be S1 plus S2 divided by delta T, say for a time interval. Okay. So since distance traveled has no direction, so this is average speed and not the velocity. Why? Because for distance, we need the magnitude. And for displacement, we need the magnitude as well as the direction, right? So here we can see that if an object is moving in a straight line path for a straight line and it travels equal distances in equal intervals of time. So we said equal distances in equal intervals of time. Then for such case, the object is said to be in uniform motion moving in a straight line. Why uniform motion? Because it is covering equal distance in equal intervals of time. Suppose from a starting point A, it goes to a starting point B, but all these time gap and distance gap are the same when it is traveling from one point to the other. For such case, if this is S1 and this is T1, the next one is also S1 and T1 and it goes on. So we can see that equal distances are covered in equal intervals of time, right? So such a motion is known as uniform motion and the body is moving in a straight line. Now, if the object travels unequal distances, say unequal distances in equal intervals of time, then it is non-uniform motion moving in a straight line. If it is again moving in a straight line, but unequal distances in equal intervals of time, how does it look like? From A to B, it is moving. Say unequal distances in equal intervals of time means this is T1. Time taken to travel. Here also T1, this also T1, and this also T1. But the distances covered, they are not the same. This is S1, S2, S3, and it goes on in this manner. So such case is also an example of non-uniform motion when the body is moving in a straight line. In such case, the object moves with increasing speed or decreasing speed, or maybe a combination of both. Somewhere the speed may increase and some other case the speed may decrease. Now, if the distances traveled in the successive intervals of times are increasing, then the speed is increasing. That means what? In successive intervals of times, say I'm talking about say 2 minutes and then 4 minutes and then 6 minutes. When I'm talking, then what is happening? I'm talking about these time gap and the distances traveled are going on increasing. In 2 minutes S1, in 4 minutes say S2, and S2 is greater than S1. That means the speed is going on increasing. Right? Now let us see some historical facts. India's scientific contribution. You know, our country is famous for art and culture as well as technology and science. The concept of an object's speed is the distance traveled divided by the time taken. We have seen that. And this idea was given when, in which phase, in which age? In the age of Aryabhatta in in the 5th century, right? The following problem based on this concept is from the comprehensive mathematical text. Okay. And this we can see from that concept only. So this is an integration of maths as well as science. Consider two postmen. They start walking towards each other from a distance of, say, towards each other. This is postman A. This is postman B. A is moving towards B. B is moving towards A. From a distance of 210 yojanas. Now, this is an ancient unit of distance. It is an ancient unit of distance which was taken in India. And with that unit, they are moving. They are 210 yojanas apart. Okay. Now, one travels 9 yojana per day and the other covers 5 yojana per day. So, you can take 5 distance unit per day and one is taking and the other 9 distance unit per day. Can you determine in how many days they will meet each other? So meeting each other means they actually need to cover this total yojana, which is 210. So if one is traveling, say A is traveling 9 yojana per day. So it is covering greater distance per day and B is covering lesser distance per day. That means their speed is differing. But they have to cover up the same distance to meet each other. Okay? To meet each other. So total distance covered by each postman in one day. What it needs to be? It needs to be 9 yojana and 5 yojana. And that is 14 yojana. Now to meet each other, the postman need to cover the total number of yojana together, right? If they cover up this total distance together, then they will meet. Time taken by them to cover 210 yojana together will be what? It will be 14 yojanas in one day. So 210 yojanas unitary method, it will be 15 days. So in 15 days, the first postman will cover how much? It covers 9 yojana in one day. So it will cover how many yojanas in 15 days? 9 into 15. And the second one covers 5 yojana. So 5 into 15. That is how you are going to solve this numerical. Now the speed tells us how fast an object is moving, but it provides no information about the direction of motion. The moment you talk about direction, that means you are talking about velocity and not speed. Velocity is speed when you are taking speed, the magnitude of it along with the direction. So we can replace it by the term displacement in place of distance divided by the time interval. Because velocity is a vector quantity. Why? Because here it depends on direction. So speed doesn't depend on direction. It depends on the ratio, or rather how much distance is covered in a particular time interval. That is speed. But velocity means how much displacement is covered, what is the change in the position of the object which is moving in a particular time interval. And like displacement, velocity is a vector quantity. That means it depends on magnitude as well as direction. Now, if we represent the average velocity as V average, the displacement by S and time taken by T, then V average is equal to S by T. Write the formulas in your copy. Put the formulas within box such that you remember. This is something important to remember, and you need to apply it in numericals, right? To express average velocity, you need to specify its magnitude as well as the direction. So how do we associate the direction with velocity when the motion is in a straight line? It's moving in a straight line path. Now, this direction of the velocity is the same as the direction of the displacement. That is what I was saying. That displacement is a vector quantity, and hence the velocity will also be a vector quantity, and it depends on the direction, not only the magnitude. It depends on magnitude as well as direction. Now, the direction of the velocity is the same as the direction of displacement and is denoted as a positive sign or a negative sign. The SI unit of average speed and average velocity will be the same. And what is that? It is meter per second. Or you can say MS inverse, meter per second. Other units are kilometer per hour. Okay, so now we can see one numerical with respect to it. And what's that? So see the note over here. For motion in a straight line, the average speed and the magnitude of average velocity in a time interval are equal. Magnitude is equal if the object moves in one direction, and what direction we are considering? In a straight line path for such case. Now see example 4.2. Sarang takes 50 seconds to swim from one end to the other end. So if this is the swimming pool, figure 4.7, this is end A and this is end B. And Sarang is taking 50-second time to swim from one end, from end A to end B, or say from end B to end A, whatever. And back to the swimming pool. It takes 50 seconds, total time taken. That is 50 seconds. Find his average speed. If I say average speed, that means total distance traveled divided by the time taken, right? So total distance traveled by the time taken, this is the average speed, and total distance will be what? 50-second time it is taking, but the distance between the two end is 25 meter. This is the diagram we are seeing. The distance is 25 meter. Fine. Then twice 25, 50 meter divided by the time taken, which is 50 second. So it is 1 meter per second. And what will be the average velocity? Displacement by time taken. Now when he starts from say point A and returns to point A again, then for that type of motion, when the person is returning to the starting point, it is displacement and time taken is 50 seconds again, and displacement is 0 when he is returning. That means when the person starts from a position and returns to the position, then the displacement is taken to be 0, and so the velocity is 0 meter per second. Do not forget to give the unit, which is very important in numericals. Next, let us see. Pause and ponder is for you to try. So let us discuss, and you can try later on again. During a family road trip, so it is a case-based, question. A situation is being given. You drive 200 kilometer north in 3 hours. So here you are traveling 200 kilometers. This is 200 kilometer north. Okay. And how much time you have taken? You have taken 3 hours time. Afterwards, you drive 200 kilometers south. Again, 200 kilometers south, and you take 2 hours time for it. Find the average speed and average velocity for the entire trip. Now let us talk about average speed. We have seen average speed means what? The total distance traveled by the total time taken. What is the total distance traveled? you have taken a trip 200 kilometer north, and you have taken a back, you came back to the south again, driving 200 kilometers. So what is the total distance covered? 200 plus 200 kilometer, which is 400 kilometer, divided by the total time taken. And what is the total time taken? 3 hours plus 2 hours, which is 5 hours. So actually the average speed will be 400 by 5, right? So 80 kilometer per hour. And I hope how you have got this answer is clear to you. Now, talking about average velocity, when the person, or say you yourself, is moving northward direction and coming to the south direction, that means you are coming back to the starting point for which your displacement is 0. So do you expect any average velocity to exist? Of course not, because displacement is 0. So average velocity is also 0. Now, 0 kilometer per hour. Under what condition is the magnitude of average velocity of an object equal to the average speed? We have just now seen that if the body is moving in same path, say straight line path, then this is the case. Magnitude of average velocity of an object becomes 0 while its average speed is not 0. We have seen velocity depends on displacement. If in one case you say, okay, the displacement is 0, the person returns to the initial position, then the average velocity will also be 0. So what is the case? If displacement is 0, if the person returns back to the initial position, then the average velocity will be 0. Let us see this part, the threads of curiosity. The reading of a speedometer of a vehicle is nearly the same as the magnitude of the velocity at any instant. That means it is same as instantaneous velocity. And what does that mean? Instantaneous velocity means the velocity at a particular instant. And what did I say? What is the term? I said instantaneous velocity. That means velocity at a particular time. If I say a time gap, that is not instantaneous, that is average. But if at a particular time t, then it is instantaneous, because you are talking for or about a particular instant. Okay. So if you are ready to go beyond, then see this. What we simply called velocity at an instant is known as instantaneous velocity. So we have already gone beyond, right? Because we have discussed what is an instantaneous velocity. As the time interval around an instant is made progressively smaller. That means if I say delta t is the time interval, and if delta t tends to 0, this symbol is tends to 0. You will come across this when you will see in mathematics, you will see all these things. So if delta t tends to 0, tends to means approximately almost 0. That means there is almost no time gap at a particular instant. Then the velocity is known as instantaneous velocity. Now, when the time interval becomes infinitesimally small, so be familiar with this term, infinitesimally small means very, very small, almost no time interval, very, very small, negligible. The average value of velocity approaches a fixed value, no range for velocity, a fixed value called the instantaneous velocity. Now, let us see average acceleration. If velocity is changing with respect to time, then what we get is acceleration of the body. Now, when you sit in a vehicle and it suddenly starts moving, You know that you cannot remain at rest. You notice a sudden jolt, right? Or maybe you are there in a moving vehicle and suddenly it stops. So you again experience a jolt. Why? Why? Now, this though Newton's law and inertia will explain it, but what we want to focus on here is the feeling of the change in the velocity. Now, you can find the change in velocity if you know the velocity at two different instants of time. Say at t1 the velocity was something, at t2 time interval. Say at time t1 velocity was v1, at time t2 the velocity is v2. Now your time interval is t2 minus t1 and the velocity change is v2 minus v1. And if I find the ratio, that means change in the velocity by the time interval, that is v2 minus v1 divided by t2 minus t1. This is the rate of change of velocity. Whenever we use the term rate, that means for a particular time interval we are talking about. So the average acceleration of an object over a time interval is the change in its velocity divided by the time taken, time interval for the change. So final velocity over here is given by v and initial velocity is given by u. So in all the expressions or equations of motion, you will see in general it is given initial velocity as u and final velocity as v. So you will use the change in velocity as v minus u divided by the time interval, which is t2 minus t1. Now, what is the SI unit of average acceleration? You know what is the SI unit of velocity. SI unit of velocity was meter per second. Divided by what? Divided by the time interval. And that is also second. So you actually got what? You got meter divided by second into second, which you can say is equal to meter divided by second square. So this is equal to meter per second square, or you can also write ms to the power of minus 2. So this is the unit, SI unit of average acceleration. So be careful regarding the units when you do the numerical. There shouldn't be any mistake, because mistake in unit will result in losing marks. So, like displacement and velocity, we need to specify the magnitude as well as the direction. Okay, magnitude as well as the direction of acceleration. So it is a vector quantity. So what did we see? That vector quantity is velocity. Velocity is a vector quantity. Displacement is a vector quantity. And now we are seeing acceleration is also a vector quantity. Why they are all vector quantity? Because they depend on magnitude as well as direction. So, average acceleration is opposite to the direction of velocity if the magnitude of velocity is decreasing. So, with respect to time, if the magnitude of velocity decreases, you know what? There is a decrease in the value of the average acceleration. And there is a term for it. You will get to know regarding this term, which is known as deceleration. Okay. So when we say that the magnitude of velocity is actually less, the magnitude of the velocity is less, then we get something which is known as deceleration. Okay. So what is deceleration? Deceleration is what? That means negative acceleration. that is known as deceleration. The average acceleration can result from change in the magnitude of velocity or change in its direction, or both may be changing. Magnitude is also changing and direction is also changing because it is a vector quantity, and we have said that. So there is something activity 4.2. Okay. So let us calculate what we will calculate. The magnitude of average acceleration of cars now is generally specified as the time taken by the car to go from 0 kilometer per hour to 100 kilometer per hour. Now look it up on the internet and find this time for various cars and record those in table 4.2. So this is something which is very, very open-ended question. You need to do a bit research of it. So please do, and I will wait in the comment section for the answers. Calculate the magnitude of average acceleration for each car. So do give it a try. It is not that hard also. So let us see this. What it is. A bus is moving on a long straight highway with a velocity of 36 km per hour. This is V, velocity. The driver presses the accelerator for a time interval of 10 seconds. So time interval is what? Time interval is 10 seconds, right? And the velocity of the bus increases from V1, the velocity is going to V2, and that is what? That is 54 kilometer per hour. So as per the convention, you can write this as U and this as V. Initial velocity U, 36 kilometer per hour. Final velocity V, 54 kilometer per hour. Time interval is 10 seconds. For some time, the bus moves at a constant velocity, right? Let us see. For some time, it is moving at a constant velocity. Then the driver notices an obstacle on the road ahead and presses the brake. The bus comes to a stop in a time interval of 5 seconds, right? So it is coming to a stop. The bus is coming to a stop at a time interval of 5 seconds. Find the average acceleration in the two time interval. So what do we need? We actually need the velocity, right? So if we need to see the acceleration, we need to see the rate of change of velocity. So initially the velocity was 36 kilometer per hour, and this 36 kilometer per hour can be changed to meter per second, and you have got this value for meter per second. Okay. So this is something, and 54 kilometer per hour is again changed to meter per second. Okay. So now over here, after changing, you should see how kilometer per hour is changed to meter per second. So how is it done? How kilometer per hour is changed to meter per second? So you see, meter per second is actually equal to kilometer per hour into 5/18. Remember this. Okay. So if you say that, okay, fine, we are going to change it, then what we will do? If we need to change kilometer per hour to meter per second, then we are going to multiply it by 18/5. So this is what we will do. So if we do, say, 15 kilometer per hour, okay, 15 kilometer per hour, we are changing it. So what we will do? We will do 15 into 5/18 to convert it to meter per second. Okay. So that is what we'll do. So let us see something like into 5 by 18 we'll do. So this is what we are seeing. I think this is 15 meter per second minus 10 meter per second. That is V minus U. Okay. By 10 seconds. So this is the rate of change of velocity. But for this, let us see 36 kilometer per hour was changed to meter per second. You can straightforward, what will you do? Straightforward, you can multiply it by 5 by 18. So 36 into 5 by 18. This many meter per second. This is how you will get. Okay. And now same thing 54 kilometer per hour. So please do 54 into 5 by 18 in order to get in meter per second. So this you will again get, for this you will get 15 meter per second, right? And this is the average acceleration. Next, what it is, let us see. When the brakes are pressed means here the body is coming to rest. So the final velocity is 0 and initial will be again the starting, that is 15 meter per second, and then 0 minus 15 by 5 and it is negative. The minus sign indicates that the acceleration is acting opposite to the direction of the velocity. It is acting opposite to the direction of the velocity, right? So let us see here what is happening. The average acceleration, okay, slowing down. If it is slowing down, then it is deceleration. The average acceleration during different time interval can either be constant or changing. For a motion moving in a straight line in the same direction, if the magnitude of the velocity increases or decreases by equal amount. So again, this is something which is showing uniform motion, same change. Okay. So for this, what we will say, if it is like it is increasing, the magnitude of the velocity is increasing or maybe decreasing, but by equal amount in equal time interval, that means the acceleration of the object is constant. Now, as we have seen, what we will see earlier, when an object is dropped from a height, this is an example. If it is dropped from a height, it takes a straight vertical path downward before touching the ground, because when it touches the ground, it comes to rest. Now, while coming down, the velocity of the object increases. Okay. So this we can see here, it was u is equal to 0. Now the velocity say v1, here v2, here v3. We are seeing the value is going on increasing. So while coming down, remember, while coming down, the velocity of the object increases at different instant. Now find the magnitude of the average acceleration of the object in every successive intervals of a second. This is the instant which is given. Is the average acceleration constant across all interval? What is the direction of this average acceleration? Let us see one by one. Now the magnitude of the average acceleration in every successive interval is being told to find out. So when it is t is equal to 0 meter, t is equal to 1 second. So let us see where it is. T is equal to 1 second. This is it. So it's in between 5 we can say, right? So what it is? Average acceleration between 0 and 1 second. This position, 0 and 1 second. That is change in the velocity. Final minus initial, 9.8 minus 0 divided by final minus initial. Okay, time, that is This one is 1 second minus 0. So 9.8 meter per second. That is, meter per second square. That is the average acceleration, because this is showing the change in the velocity for this particular time interval. Now, if we say from t is equal to 1 second to again t is equal to 2 seconds. This is again what is happening. Time interval is 1 second only. For this, what is the final velocity? 19.6, initial 9.8. So again, the change in the velocity divided by the time taken. Again, you can see 9.8. Like that, you are doing it for every time gap. You are seeing the velocity change, dividing it by the time interval, and in each case you are seeing, okay, the acceleration is coming to be, average acceleration is coming to be 9.8 meter per second square. Everywhere it is same. So the average acceleration is constant and equal to 9.8 meter per second square. So as the velocity is increasing in the direction of motion, acceleration is to which direction? It is in the direction of motion. Understand? As the velocity is increasing in the direction of motion, we have seen from 0 to 39.2 meter per second square, there has been an increase in the velocity. So the velocity is going on increasing in the direction of the motion only. So acceleration is in the direction of motion. What is the direction of acceleration? The direction of the motion. Now this acceleration is termed as acceleration due to gravity or gravitational force. Okay. And it is denoted by small g. That is how you said that, okay, fine, small g can have the value 9.8 meter per second square. Now, did you notice in the figure that we chose the origin at the ground level? Okay, while in figure 4.10, 4.5, we have chosen at the ground level. Okay, fine. We are trying to reach to that 4.5 where we can see at the ground level. Okay, so here we are not having. So 4.5 was at the ground level, whereas 4.10 is what? At some height. We choose the origin from where the object is being dropped. This is A, and here this is B. Before it reaches the ground is B. In this example, we use downside as positive. Okay, downward direction as positive. Now we can choose the origin and positive direction as per our convenience. Now, if this is positive, then if the object is thrown upward, that needs to be negative. Okay. So just as we have something called instantaneous velocity, we have something called instantaneous acceleration. That is the acceleration at a particular instant. So please try to recall what is average velocity, what is average acceleration, when it can have a zero value, how it depends on the direction as well as the magnitude. So bye all of you. See you in the next topic.